Hello, gang. Today we're going to look at Chapter 9, which is all about access control lists. We're going to talk about how IP ACLs work. We'll talk about standard and extended lists. We'll talk about a little bit of debugging with an ACL and troubleshooting. And we will touch on IP6 access control lists. We'll talk about how ACLs are used to filter traffic. We'll compare extended and standard. We'll talk about wildcard masks, which are a little bit different. ACLs use wildcards instead of subnets. And you've been exposed to those before. Remember, they're basically just the opposites. We'll talk about some guides for creating and placing ACLs. And then we'll look at just a standard ACL to filter traffic. And then finally, we'll show that you can use an ACL to stop access to the console. We'll go on to talk about the structure of extended access control entry, which is ACE. We'll talk about extended IP4 ACLs to filter based on different network requirements. Basically, you can filter with an ACL on any kind of thing you want. We'll use some CLI commands to look at ACLs, and then we'll look at the difference in the 4 and the 6 ACLs. So the first question we should really answer is, what is an ACL? ACL stands for Access Control List. And an ACL basically is just a short program that's written that has lines in it that either permit or deny traffic based on certain settings. And based on how your network is set up, it will determine where you want to put those ACLs and what you want to block with them. So here we're talking about a typical TCP/IP conversation. And if you remember back where we first started talking about your three-way handshake, first we send a sync command and then we get a sync acknowledgement. Then we send an acknowledgement and actually send our data. Then we'll get an acknowledgement and more data, and that will continue until we send an acknowledgement and then a finalize acknowledgement, and then an acknowledgement of that finalize, and that ends the handshake. So it's important to remember this as we start talking about ACLs, because this is what will be interrupted with a proper ACL. So the big purpose of an ACL is to filter packets. And this is usually called static packet filtering. It's a way to control access to your network by analyzing the incoming and outgoing packets. And that's important. And the reason I stress that is, in general, we tend to think about firewalls as just being stopping data from coming into a network. And for most of us at home, that's really all we need it to do. We want it to stop things coming in. We don't really worry about going out. But it's important to note that you can make access control lists that are incoming and outgoing. So not only can they stop certain traffic from coming in, but you can turn them around and restrict traffic from going out. And a quick example of that might be if you want to install some sort of proxy server to filter your web traffic. Well, you can put a proxy server in and then only allow the proxy server to send data out port 80 or 443, HT or HTTPS. So by doing that, then all of the machines inside the network that want to communicate with the web are going to have to go through the proxy, because it's the only device that's being allowed to transmit out. So a router acts as a packet filter when it forwards or denies packets based on rules. And an ACL is just a sequential list of either permit or deny statements known as access control entries. So each line of an ACL is essentially an ACE. So here we've got just kind of a basic diagram showing a packet filtering example. And this is just a little flow chart that they give you can follow to see how to build an ACL. And if you look at the top, we're going to get a header coming in with an IP packet. And first it's going to say what network, and in this case we've got A or B. And then our ACL is saying, are we going to allow port 80? If yes, we'll have an allow statement. If no, we'll have a deny statement. Port 80 we know is web traffic, so the question becomes, is our ACL going to allow data in on port 80? If the router determines it's for network B, same thing. We have a separate ACL for network B. It's going to say port 80 again, are we going to allow or deny? And we've got the same set of rules in both in this case. So if it's a yes, it will deny. If it's a no, it'll allow. So there are two types of ACLs that are in use, inbound and outbound. And this is back where I was telling you it's important to remember that a firewall, we generally think of it only blocking traffic coming in, but it can also block traffic going out. So the ACL for the inbound filters packets coming into a specific interface before they're routed to the outbound interface. An outbound ACL filters packets after being routed regardless of the inbound interface. So it's important about where you place them as to what they're going to do. The last statement of an ACL is always an implicit deny. This is automatically inserted at the end of the ACL even if it's not physically present. The implicit deny blocks all traffic. Because of this implicit deny, an ACL that does not at least have one permit statement will block all traffic. So this is for security, and basically what you should understand here is the general rule with an ACL is block absolutely everything. And the reason for that is because a deny all command at the end is going to hit so that that command is always used. If you've got a good firewall, you are allowing traffic on certain ports. If something comes in for a different port, it's going to block it automatically. That's just security. Now you can override that by making the last command in your ACL allow all, but that defeats the purpose of even having a firewall because now you're allowing all traffic on all interfaces. So a standard ACL is just IP. In this example, they're going to show if you've got, like, in their case, they're using access list 10, and they're permitting 192.168.30.0, so they're permitting a whole network. Notice at the end they've got 0.0.0.255. That's those wildcards we were talking about earlier. Instead of using a subnet mask, which the subnet mask, you know, for a typical C would be 255.255.255.0. With ACLs, in order for the traffic to match, you have to use the wildcard. And the wildcard, the easiest way to explain it, it's just the exact opposite of the subnet. So an extended ACL, though, on the other hand, includes more than just IP addresses. And in their example here, they're going to say access list, they're using line 103, which tells us that in a program these would be numbered. 103 is going to happen down below it. And in this case, we're going to permit TCP, so we're telling it exactly what kind of traffic. 192.168.30.0 is the example again with the 0.0.0.255. And at the end, they put any EQ80, which means they're saying that anything equivalent to 80 permit TCP traffic on. So basically, this is extended ACL command will allow us to open that up for specifically a web server because port 80, you know, is our web traffic. So it's important that you understand the purpose of numbering the ACLs. 1 to 99 and then 1300 to 1999 are standard IP ACLs. 100 to 199 and 2000 to 2699 are the extended. And your numbers are important because the first number that the ACL that you set reaches that hits, then that action is taken. For example, if you put a line, let's say line 100 says permit port 80 on IP whatever, and line 101 says deny port 80 on whatever, well, you're allowing that IP traffic through on port 80 because line 100 is going to reach before the other one. That's why the deny all command is at the end of an ACL, because no matter what your commands are, when they hit, it's going to let the traffic exit. But if it doesn't match anything, it'll drop the packet at the very end because it doesn't have any, reaches that last command or that last line, and it always hits. So you can also name ACLs, and the name contains alphanumeric characters. They suggest it be written in upper capital letters in uppercase, but you don't have to do that. Names cannot contain spaces or punctuation, and you can add or delete entries within the ACL based off the name. So I've talked about it, but here they want to make sure you understand a wildcard mask and subnet masks differ in the way they match the binary ones and zeros. Wildcard masks are exact opposite. If a wildcard mask is a 0, it matches the corresponding bit value in the address. If it's a 1, then we ignore it. Wildcard masks are often referred to as an inverse mask. The reason that, unlike a subnet mask, which a binary 1 is equal to match and a 0 is not a match, the reverse is the case in the wildcard. So here they're going to give you just a little example of that. Here we see the IP address, wildcard mask 0.0.0. You see that they're just the opposites. And here they're showing that that's what's used to make a match based off of an access control list. So calculating it, they say, can be challenging, but a shortcut is to subtract the subnet mask from 255.255.255.255. So, for example, here they're showing if we know that it is 255.255.255.255, we can subtract all of those out and realize the wildcard of that is 0.0.0.0. So here we've just got two more examples. If it is 192.168.10.10, 0000, that matches all of the IP address bits. So we can abbreviate the wildcard mask. And in our other example, we can put the word any instead of the wildcard mask because everything is going to match. Here they're just showing again using the permit any line instead. Now remember, it's not necessary that you use this. You can specify it every time. And when you're first creating ACLs, you may find it easier to do that, to specify the wildcard mask every time, simply to get yourself in the habit of that. But later, if you want to go back and use these shortcuts, they're available for you. So there are lots of guidelines for ACLs, and honestly, it will change from situation to situation. But these are some of the general rules they'll give you. That can be used kind of when you're setting up a network. So use ACLs in firewall routers positioned between your internal and external networks, such as the internet. So on your outside router is a good place to put an ACL. You can also use an ACL on a router positioned between two parts of your network to control traffic entering, exiting a specific part of your network. For example, you can put a firewall, then have an internal DMZ, and then have another firewall. And you can make very specific rules on the second firewall that keep traffic from coming in and out except to machines that are in that DMZ, that demilitarized zone that you just created. Then your outside firewall will permit traffic through from those IPs. You can configure ACLs on border routers, which are the routers that are situated at the edges of your networks. And you can configure ACLs for each network protocol configured on the border router interfaces. So you can go a little further and specify that your border routers will allow certain types of traffic based on what that traffic is. So they give you this list called the 3 Ps for creating access control lists. And in their example here, they say 1 ACL per protocol. So to control traffic flow on an interface, an ACL must be defined for each protocol enabled on the interface. Then they say 1 per direction. ACLs control traffic in one direction at a time on an interface. So if you want inbound and outbound control, you have to create inbound and outbound control. And then finally, 1 ACL per interface. ACLs control traffic on a specific interface. So for example, here they gave gigabit Ethernet 00. That's going to have a different ACL than if this router has a serial interface. Serial 00 and 01 are going to have different ACLs. So here are some of their guidelines on ACLs. Base your ACLs on the security policy of the organization. This will ensure that you implement organizational security guidelines. Prepare a description of what you want your ACLs to do. This will help you to avoid inadvertently creating potential access problems. Use a text editor to create, edit, and save ACLs. That will help you create a library of reusable ACLs. I think that is a great best practice, and it's something that I strongly encourage you guys to do. As you start playing around with ACLs, open your notepad folder and just create, a notepad file and create your ACL in it. And that's a good idea just to have it and save it. That way, if you you need to do anything to your router, you want to change it, you want to take it out, maybe you're having a problem and you're really not sure what it is. So you think it's a problem with your access control list. Well, one way you can test that, and granted you don't want to do this for long, you can issue a command, shut your firewall down. If all of a sudden your problem goes away with your firewall down, well, there you know it's a problem with your ACL. So bring your ACL back up, and then you can start trying to figure out what commands you need to add to that ACL to get the traffic through. And then test your ACLs on a development network before implementing them on a production network. This will help you avoid costly errors. If you have the capability of testing before you implement, you should do so. Even if that is not a full-scale test, even if you just rebuild your network in pieces into Packet Tracer and then run the tests that need to be run on the Packet Tracer files to see that it works before you actually issue these commands to routers. That way you don't spend time going back and that you've killed a production network that you've got to figure out what to do with. So every ACL should be placed where it has the greatest impact on efficiency. The basic rules are, for extended ACLs, locate them as close as possible to the source of the traffic to be filtered. Because standard ones do not specify destination addresses, place them as close to the destination as possible. Placement of the ACL and therefore the type of ACL used may also depend on the extent of the network administrator's control, the bandwidth of the networks, and sometimes for ease of configuration. While they say to place them closer to the source, sometimes that's a harder sell because if you've got a huge network, that could be anywhere out on your network. You may decide for ease and efficiency from the standpoint of the admin that you want everything on your core router because that's more under your direct control. Now, this was a bigger deal than it in the old days than it is now, and the reason is because these ACLs take up quite a bit of CPU time. And if you had a router that was not very powerful, you were taking time away from it being able to route if it had to go through an ACL list, a big ACL list every time. But now, since routers have got so much more memory and processing, it's not as big a deal as it once was. So here we've got just an example showing some places to put your ACLs. And if you look, they want all traffic blocked from 192.168 10.0 to 30.0. So their filter is going to be on this interface on router 3 and on switch 3 to block that specific traffic. Here they're just going through that again. In this example, we're going to block FTP traffic. So here we're going to enter a couple of commands to actually do it. Access list 1, for example, we're going to permit IP 192.168.10.0 on 0.0.0.255. So we're allowing that whole network. Then we're going to permit IP on that network. Then we're going to issue a deny any. So here, looking at these commands from our example ACL, here's what's going to happen. On gigabit 00, the packet header is going to look in. It's going to say, is it asking for network 192.168.10.10, specific IP here. We're denying that host access, so if it is, it's an automatic deny. No, then go on to the next ACL command, asking for 192.168.10.0. Yes, permit it. No, go to the next one. Are we asking for 192.168.0.0? We have a deny command there. If it is, then deny it. No, go to the next one. Are we asking for 192.0.0.0? Yes, we're going to permit that based off this rule, so let it. And if no, then we're going to drop the packet automatically, because remember, our last command is always an implicit deny. So if the traffic doesn't match any of these rules, it's going to get dropped. It's not going to get to go through anyways. So the full syntax of a standard ACL command is like this. Access list space and then the number. Deny or permit. Which one are you going to do? The source and then the source wildcard. To remove the ACL, the global configuration command is the no access list command. And the remark is used to document lists that makes it easier for you to understand them. So you can add those remark commands to say what you've done for something specific. That comes into play especially if you have to allow some weird port for something that's not standard. While it's not a bad idea to remark everything, once you work with these, you'll start remembering port 80, for example, as web traffic. You don't really need it to be specified that it's web traffic. But maybe you've got port, I don't know, say 3390 open for some reason. And 3390 is not a real common one. In fact, I don't know what 3390 is right off, but maybe you've opened it for some video conferencing something or another. So you might put a note in there that says port 3390 is open because of this, to allow data here or whatever. So Cisco IOS applies an internal logic when accepting and processing standard ACLs. As discussed previously, the ACL lists are processed sequentially. Therefore, the order of the statements entered is important. This is why they say to enter them all in a text editor and then add them, because the order that they're entered in is the order that they are used in the system. So if you go back and decide you needed to add a command, you would have to retype your whole ACL to put it in the right spot. And if you've saved that in a text file, it's easy enough to just issue a no access control list command to get rid of it, then copy and paste the whole ACL back into the system. So after a standard ACL is configured, it has to be linked to an interface using the IP access group command. So to do that, we got to go to our config interface mode. We're going to type IP access group and then the access control list number or name and then the direction, whether we're going to use it for in or for out. So here we're just seeing that. We've got a access list 1 here. We're going to deny 192.168.10.10, but then we're going to allow everything else. And then we're going to have to go to our interface gigabit 00 where we want to apply it. And then we'll IP access group 1 in. So now I'm going to look at traffic in there. Here they're just showing creating a named ACL. So IP space access list, whether it's going to be standard or extended, and then the name. Below that, if we want to permit, deny, source wildcard, and then you can log packets. That's important. You don't honestly log packets very often because these logs get big unless you think something's going on and you're trying to diagnose something. And then finally, if you're using a name, instead of putting the number, you'll use the IP access group space name, whatever you named it, and then in or out to activate it. So here they're just showing using a remark. Here in 1, we're going to deny, and then we have what we're doing as a remark. Those remarks, you can put anything after. So you really just come up with something that helps you understand what it is. It doesn't matter what goes there. So here they're showing how to edit one. And again, they do it with a text editor because it's so much easier to do that and then send the commands one at a time. Here to see what we've done, we can do the show access list command. And we see we have 2 in this case. And here again, the no command is used to delete a line out. So we can verify them because when we show IP interfaces now, we should see that there is an access, an inbound or an outbound access list. In this case, it shows outgoing list is 1, inbound is not set. Looking at another one, we see that it's got a name, so we're seeing no access. I think it's important, I want you to note here that the underscore is in there. They don't consider the underscore to be punctuation, so you can put spaces, in a sense, in your access control list names by using that underscore. That's the only punctuation that's allowed, though a period is not allowed. So here, if we show access lists, we can see that 8 matches have hit, so 8 packets have been dropped using this deny command. So another part of the iOS internal logic involves the sequencing of standard ACL statements. Range statements that deny 3 networks are configured first, followed by 5 host statements. The host statements are all valid because their host IP addresses are not part of the previously entered range statements. The host statements are listed first by the show command, but not necessarily in the order they were entered. The iOS puts host statements in an order using a special hashing function. The resulting order optimizes the search for the ACL host entry. So what they want you to understand here is that it may change around some of your first commands. Another thing you may wish to do is use the ACL command to secure access to the router itself via Telnet or SSH. And this is an extended IP ACL because it filters a higher protocol. However, the access class command is used to filter incoming or outgoing Telnet or SSH sessions by source address. So what we can do is, if you don't want anybody to be able to get to your routers except from, say, computing services or from your office or from the network office, you can add ACL commands so that they port access to the router itself is only available from your IP address or from your subnet. And here they're just giving an example of that. So extended ACLs can filter on a lot more than a basic ACL. Now we're adding source address, destination, protocol, and port numbers. So these look a little different. Using port numbers, for example, access list 114, permit TCP 192.168.20.0, then 0000255. So we're allowing that whole subnet with port 23, which I need to go back and look because it's been a while, but I think 23 is FTP. 21 below it, I believe, is Telnet. It looks like I may have those backwards. Assuming they put these in the same order, 21 and 20 are FTP and 23 is Telnet. But they're showing down here below that you can use keywords. Permit Telnet and permit FTP are a command that I would never want to see in my own network because they're insecure. So the steps for configuring an extended ACL are the same as for standards. First, the extended ACL is configured, then activated on an interface. However, the command syntax are a little more complex because we have more in it. So earlier, where we just had a couple of commands, we've still got deny, permit, or remark now, but now we got a protocol source and a source wildcard, then a port, a destination, and then a port or a name, and then we can add the established command if we want to allow it to establish or break it. Here they're just giving an example of that. And here we're just looking at, for example, an ACL to deny FTP. So deny, the commands can be deny TCP. This is our network, so anything on 192.168.11.0 going to 10.0, we're not going to allow FTP through. And here via name, the same thing. So we can show, and we'll see the same thing now. If we do a show IP interface, we'll see that we have an outgoing and an ingoing. And we've named them, in this case, browsing and surfing. So creating an extended ACL can be done just very much like a standard ACL with a text editor or with sequence numbers. I'm a firm believer in that you should use a little text editor so you can keep these. The logic is the same as it was before. Packets are tested against an inbound. If one exists before it happens before routing. An inbound packet matches an ACL statement with a permit, it is sent to be routed. If an inbound packet matches an ACL statement with a deny, it is dropped. And if an inbound packet does not meet any ACLs, then it hits that implicit deny statement at the very end, so it's dropped. On the outbound side, packets are first checked for a route before being sent to an outbound interface. If there is no route, it's dropped. If an outbound interface has no ACL, the packets are sent directly onto the interface. So if we don't configure outbound, we're going to allow it. If there is an ACL on the outbound, it is tested before being sent to the interface. If an outbound packet matches an ACL statement with a permit, it is sent to the interface. If an outbound packet matches an ACL with a deny, it is dropped. But remember, if we turn on ACLs on outbound, if it doesn't meet any ACL statement, it hits the implicit deny at the end, and it is automatically dropped. So the logic of that is that when a packet arrives at a router interface, the router processes the same whether the ACLs are used or not. As a frame enters the interface, the router checks to see whether the destination layer 2 address matches its interface layer 2 addresses, or if the frame is a broadcast frame. If the frame address is accepted, the frame information is stripped off and the router checks for an ACL on the inbound interface. If an ACL exists, the packet is tested against that list. If it is accepted, it is checked against routing table entries to determine the destination. If a routing table entry exists, the packet is switched to the outgoing interface. Otherwise, it's dropped. So remember, if we don't have anywhere for it to go, these ACLs don't matter. Once it's assigned to that interface, the router checks to see if there is an outgoing interface ACL on that interface. If it exists, it's going to be tested against it. If there is no ACL or the packet is permitted, it is encapsulated in a new layer 2 frame and forwarded out that interface. Standard ACLs only examine the source IP4 address. The destination of the packet and the ports involved are not considered. Cisco IOS tests against all conditions in the ACL. The first match determines whether the software accepts or rejects the address. Because it stops testing at the first match, the order of those conditions is critical. Remember my example earlier, if we have a deny and then an allow on port 80 on the same IP, but deny is listed first, we're going to hit that first and it's going to exit. It's not going to matter that we allow it below it. If no conditions match, then we hit that implicit deny again and we're rejected. The ACL first filters on the source address, then on the port and the protocol of the source. It then filters on the destination address, and then on the port and protocol of the destination, and makes a final permit or deny based off of that. So it's important to remember that as you craft these commands. So here we got an example, a common ACL error. In this case, host 192.168.10.10 has no connectivity with 192.168.30.12. And if we look further into it, different example. If we look into it, it's this first command, deny, that's making it not reach. And we have 12 matches, so 12 packets have been dropped because they hit that command. Even though we have a permit any down here, they're getting denied before they reach that. Here, 192.168.10.0 cannot use TFTP to get 230.0. And the reason is, again, they're deny statements. In this one, 192.168.11.0 can use Telnet to connect to 192.168.30.0, but according to policy, this connection shouldn't be allowed. So we're saying that we shouldn't allow traffic, but our command is actually allowing it because we have a permit any down here. So IP6 ACLs are very much like 4, except that we don't have numbered. We only have named IP6s. And they're basically all the same as IP4 extended ones. Here they're going to say that although IP4 and 6 are similar, there are 3 significant differences. IP6 uses the IP6 traffic filter command to perform the same functions. There are no wildcard masks. Praise the Lord, hallelujah. We do not have to figure out how to do an IP6 wildcard. The prefix length is going to be used to determine how much of a source or destination should be matched. And there's a couple of additional default statements. We are going to permit ICMP from any on 2 matches. So here we've got an example of an IP6 topology, and we'll look at how to actually create an ACL on IP6. And in order to do that, first from global config mode, we'll do the IP6 access list, and then we'll name it. From the named ACL list, we'll add our permit or deny statements, which will determine if a packet is forwarded or dropped. So here we show again where to place it. Placement would be very much with the same rules of IP4. Here they're going to deny FTP, for example, on certain addresses using an IP6 ACL. And down here we're going to have a couple that will restrict access. Verifying an IP6 ACL, we can use our same commands to look at it, except this time we'll show IP6 on whatever interface, and we should see an inbound or an outbound. Now they didn't specify it, but this is a good point to put in. An IP6 ACL, very much like a 4, is going to have an implicit deny as the last line. So again, you've got to have traffic that matches, but if it reaches that last rule, it's going to get denied automatically if you haven't added a rule to permit it. So by default, your routers are not going to filter any traffic. Instead, traffic that enters is routed solely based on the information within the routing table. Packet filtering is going to control access to this network by analyzing the incoming and outgoing packets. Packet filtering routers use rules to determine whether to permit or deny traffic. And an ACL is a sequential list of permit or deny statements. The last statement of an ACL is always an implicit deny. To prevent the implied deny, you should end any ACL with permit IP any. So if you want to just deny certain things, but you want to allow everything else, stick that permit any as the last line, and that'll take care of that implicit deny, because that implicit deny will never be reached. When a network traffic passes through an interface configured with an ACL, it compares the information with the packet against each entry in order to determine if the packet matches. ACLs are configured to apply to inbound traffic or outbound traffic. Standard ACLs can be used to permit or deny traffic only from the source IP4. The destination of the packet and the ports involved are not evaluated, but we can do that with extended ACLs. The access list is the global config will tell you how to set up your ACL. You can do 1 to 99 for standard, or extended with 100 to 199 and 2000 to 2699. Or again, you can do a name and put this in sequentially with a text editor, which is my suggestion. The IP access list name is used to create a standard named ACL, or extended name to create an extended name ACL. And then finally, remember those 3 P's we talked about. 1 ACL per protocol, 1 per direction, and 1 per interface. Remove an ACL with the no IP access group command, and then enter it into the no access list command to remove the entire ACL. Then do a show run or a show access list to see that you've got everything set up the way you think you do. Finally, the access class command is used to configure to restrict access to the actual router itself. It's interesting now, I want to point out there's 2 ways to do that. We show here that one way we can block it is with this access class command, but there is no reason that you can't just input a deny command in your ACL on the proper interfaces and put the IP address of the router itself in the access control list so that you are denying access to it from everywhere except certain places. That'll block that list. Remember, your list logic, anytime you go down it, when you reach a certain point, it'll stop. So if you put an allow only from, say, the IP address in your administrative subnet, and then you do denies everywhere else, well, if it hits that first implied allow, then the data will go out. But if it goes on down and hits deny all SSH, for example, it'll hit that command and stop it. And finally, your IP6 ACLs are very much like IP4s. The only difference is that all IP6 ones are named instead of numbered, and they all basically act like extended ACLs. And remember, you don't have to use a wildcard for an IP6. So you can set up your IP6 with a text editor, and the order of everything is going to be way more important. And that is a quick rundown of Chapter 9.